It starts out with a small weight that will go into this plastic glass and would lift this washer. That makes the pulley. Then the washer will hit this small ball that will go into the screw. It will come out the screw and go to this inclined plane until it hits the first wheel and axle. The wheel and axle will then hit the second wheel and axle, and then it will hit the third wheel and axle. The third wheel and axle will hit the ball, which will go into the second screw. The ball will go out in the second screw and into the second inclined plane. Then it would hit the first lever that will push the second lever and will make the golf ball roll. The golf ball will knock down the dominoes and hit the third lever. The third lever will then push the bottle of Coke, and then the Coke will be served into the other bottle.
In this part of the machine, we have two energies, potential energy and kinetic energy. Potential energy is the energy that is stored. We can see gravitational potential energy here because the object is at rest. Kinetic energy, on the other hand, is the energy of motion. It depends on both mass and speed. We could see kinetic energy if the object was moving. Right now, there is 100% potential energy, but if the object started moving, kinetic energy could start increasing. Right before the object stops, kinetic energy is at its maximum, but when it stops, kinetic energy goes again to zero. The law of conservation of energy says that energy cannot be destroyed or created. It can just be transferred from one object to another. In this part of the machine, we have speed and velocity. The formula for speed is distance divided by time. The calculated speed in this part of the machine is 2 meters per second. How we got that speed? It's easy. We divide distance divided by time, which in this case was 1.2 divided by 0.6, which that equals 2. So 2 meters per second. Velocity, on the other hand, is also speed, but included with direction. The velocity for this type, in this case, is 2 meters per second northeast. In this part of the machine, we can see acceleration. The formula for acceleration is final velocity minus initial velocity divided by time. The acceleration for this inclined plane is 0.75 meters per second squared. The calculated velocity for the first half is 1.63 meters per second, and the calculated velocity for the second half is 2.16 meters per second. If you subtract 1.63 meters per second from 2.16 meters per second, and you divide it by the total time, which is 0.7 seconds, you get the acceleration, which in this case is 0.75 meters per second squared. In this part of the machine, we can see force. A force is a push or a pull. We can see contact force here, when the object pushes against the other and applies contact force to the other. That's why it's a force. This part of the machine demonstrates Newton's first law. Newton's first law states that objects at rest stay at rest. Objects in motion stay in motion with the same velocity unless acted upon by an unbalanced force. In this case, the golf ball is at rest and will remain at rest unless I use an unbalanced force. The unbalanced force in this case would be the lever. If I use the lever, the golf ball will go and accelerate, but then it will stay in motion until it's stopped by an unbalanced force, which in this case is the dominoes. This part of the machine demonstrates Newton's second law. Newton's second law states that acceleration increases with increased force and decreases with increased mass. For example, if I push this golf ball with little force, it will have less acceleration than if I push it with lots of force. This part of the machine demonstrates Newton's third law. Newton's third law states that every time an object exerts a force on another object, the second object exerts a force that is equal in size and opposite in direction back on the first object. For example, here, the wheel and axle hit the second wheel and axle, exerting a force that is equal to the force that the second wheel and axle exerted back on the first wheel and axle. Now I will show you my 5 simple machines that I used in the project. First is a pulley. When I deposit a weight in this glass, this side will go down as the other goes up. My second simple machine is a screw. A screw is just an inclined plane turning around a circle point. It will then go to the inclined plane that has a high point and a low point for acceleration to be in the middle. Then we go to the wheel and axle. It's a combination of the wheel and an axle, so that the wheel be the turning point and the axle be the connection. Then we have the levers. Here we have a first class lever. When you have an input force, the fulcrum and the load. Now let's see how the complete Rube Goldberg machine works. I hope you liked my Rube Goldberg machine. Thank you for watching.